Welcome to Math 0420, Intro Algebra. In this lesson, we will be discussing Section 1.1, Introduction to Algebra, Variables and Mathematical Models. In this section, we will evaluate algebraic expressions, translate English phrases into algebraic expressions, determine whether a number is a solution to an equation, translate English sentences into algebraic equations, and evaluate formulas. Let's get started. Let's start with a definition. A variable is a letter that represents a variety of different numbers. Also, another definition, a combination of variables numbers and operations is called an algebraic expression. Now that we have those definitions, we want to move on to talking about evaluating algebraic expressions. Here are the steps for evaluating an algebraic expression. Step 1. You want to perform all operations within grouping symbols. Grouping symbols are brackets or parentheses. The next step is to do all multiplications in the order they appear from left to right. The next step, not 4, step 3, is to do all additions and subtractions in the order in which they appear from left to right. Let's try an example. Example 1. We want to evaluate, let's try that again. Evaluate each expression for x equals 10. Our first expression is 6 plus 2x. Okay, so what we want to do to evaluate the expression is everywhere we see an x, we want to plug in x equals 10. So we can plug in 10 for x, and we get 6 plus 2 times 10. So now we evaluate the multiplications from left to right. So that's 2 times 10. So 6 plus 2 times 10, which is 20. And then we evaluate the additions from left to right. 6 plus 20 is 26. Okay. Okay, another example. 2 times the quantity x plus 6. Well, we know that x is equal to 10. So in for x, we will substitute 10. So we get 2 times 10 plus 6. We have to evaluate within those grouping symbols, those parentheses. So we keep the 2 on the outside and we do the addition on the inside, which is 10 plus 6, or 16. And then we evaluate that multiplication, 2 times 16, which is equal to 32. Let's try another example. Example 2. This time we want to evaluate each algebraic expression. Let's try that again. Algebraic expression for x equals 3 and y equals 8. So for our first part, if we have 7x plus 2y, we can substitute x equals 3 everywhere we see an x, and y equals 8 everywhere we see a y. So we plug in 3 for x and an 8 for y. And then we can perform the multiplications from left to right. 7 times 3 is 21. 2 times 8 is 16. 21 plus 16 is 37. For part B, let's try 6x minus y divided by 2y minus x minus 8. So everywhere we see an x, we'll plug in 3, and everywhere we see a y, we'll plug in 8. So 6 times 3 minus 8 divided by 2 times 8 minus 3 minus 8. Okay, so we can perform the multiplications from left to right in the numerator and denominator. So we have 18, 6 times 3 is 18 minus 8 divided by 2 times 8, which is 16, minus 3 minus 8. 18 minus 8 is 10, and 16 minus 3 is 13. 13 minus 8 is 5. So we have 10 over 5, which is equal to 2. Next, we need to talk about translating English to algebraic expressions. And one of the ways we can do that is to look for keywords. So there are keywords that mean the same thing as each of the 4 operations. So for addition, other words that mean addition are plus, sum, more than, or increase by. Keywords for subtraction are minus, difference, less than, or decrease by. For multiplication, you may see the words times, product, twice, multiplied by. And for division, you might see divide, quotient, ratio, or divided by. So anytime you see one of these words in a sentence, you know which operation it corresponds to, whether that be addition, subtraction, multiplication, or division. You can also find this table of keywords in Table 1.1 of your textbook. Let's do an example. Example 3. We want to write each English phrase as an algebraic expression. And we want to let the variable x represent the number. Okay, we're going to do 5 different ones here. Part A will be the product of 6, let's try that again, of 6 and a number. Part B will be a number added to 4. Part C will be 3 times a number increased by 5. D is twice a number subtracted from 12. And lastly, E is the quotient of 15 and a number. Okay, so let's answer each of these. For part A, the product of 6 and a number. Remember, product means multiplication. So the product of 6 and a number would be 6 times x, or just 6x. For B, we have a number, which is x, added, which means addition, to 4, which is 4 plus that number, which is x. Part C, 3 times a number, multiplication again, increased by 5. So 3 times a number is going to give us 3x, and then we increase it by 5 by adding 5. Okay, D, twice a number subtracted from 12. So we have twice a number, so 2x, and we're subtracting that from 12. So you have to be a little bit careful with subtraction. So we need to start with 12 because it's being subtracted from 12. So 12 minus twice a number, which is 2x. And finally, part E, the quotient of 15 and a number. Quotient means to divide, so the quotient of 15, so 15 divided by a number, which is x. So 15 over x. Now that we've discussed algebraic expressions, let's now talk a little bit about equations. And to get started, we need a definition. An equation is a statement that two algebraic expressions are equal. And we typically put an equal sign between them. Another definition involves the solutions of an equation. Solutions of an equation are values of the variable that make the equation a true statement. Let's try an example. Okay, example 4. We want to determine whether the given number is a solution of the equation. And for our first part, we have the equation 9x minus 3 equals 42. And we want to check to see if x equals 6 is a solution. So what we do is we take x equals 6 and plug it in everywhere we see an x in the equation. So 9 times 6 minus 3, not equals, minus 3, equals 40. Oops, we don't want to say it's equal to 42. We want to check and see what it is equal to. 9 times 6 is 54, minus 3. And 54 minus 3 is 51. Well, 51 is not equal to 42 as we needed in our equation. So since 51 is not equal to 42, x equals 6 is not a solution to the equation. Nine x minus 3 equal to 42. Let's try another part. If we have 2 times the quantity y plus 3 equals 5y minus 3, and we want to check to see if y equals 3 is a solution. Okay, so we can plug in our y equals 3 in both places we see a y. So we have 2 times the quantity 3 plus 3 equal to 5 times 3 minus 3. On the left-hand side, we evaluate inside the parentheses. So we have 2 times 3 plus 3, which is 6. On the right-hand side, 5 times 3 is 15 minus 3. 2 times 6 on the left-hand side is 12. And 15 minus 3 is also 12. Since we end up with 12 equal to 12, we have a true statement. So since we end up with a true statement, y equals 3 is a solution to the equation two times the quantity y plus 3 equals 5y minus 3. Let's now start talking about translating English to equations. So when we see the equal sign, we may see some other words that represent equals. So we may see equals, gives, yields, is the same as, is, was, or will be. Just like when we were dealing with the operations, addition, subtraction, multiplication, and division, this symbol can be represented by all of these words. So we'll now try and do an example where we translate from words to an equation. Example 5. We want to write each sentence as an equation. And then we will let the variable x represent the number. For the first one, we have the quotient of a number and 6 is 5. And then the second one is 7 decreased by twice a number yields 1. So for the first part, we need to notice that we have the quotient of a number and 6. So the quotient of a number, so that's x, divided by 6. And then we have the word is. Remember back to the previous slide, is represents the equal sign. Is 5, so equals 5. Okay, our next part B, we have 7. We start with 7. And then we decrease by twice the number. So we take twice a number away, so 2 times x yields 1. Remember, yield also represents equals, so yields 1. Okay, that's example 5. The last topic of this section is evaluating formulas. So first we need a definition or two. A formula is an equation that expresses a relationship between two or more variables. A formula is an equation that expresses a relationship between two or more variables. And another definition, the process of finding formulas to describe real-world phenomena is called mathematical modeling. Formulas that are found as a result are called mathematical models. Let's do an example. In our last example of the section, I pulled this example directly from your textbook. Example 6, the bar graph shows the average price of a movie ticket for selected years from 1980 through 2010. The mathematical model that approximates the data displayed by the bar graph shown below is the equation t equals 0.17n plus 2.46, where t is the average movie ticket price and n is the number of years after 1980. So there are two questions that we want to answer for this example. In part A, we want to use the formula to find the average ticket price 10 years after 1980 or in 1990. Does the mathematical model underestimate or overestimate the average ticket price shown by the bar graph for 1990? If so, by how much? So for part A, we know that our n, which is the number of years after 1990, is 10. So n equals 10. So if we use the model from this equation, we can say that t is equal to 0.17 times 10 plus 2.46. So let's see what that estimate gives us. Well, 0.17 times 10 is 1.70 plus our 2.46. And when we add those together, we get $4.16. Well, how does that compare to what the actual average ticket price in 1990 was? Well, that's 4.16. If we look at the actual price, it was actually 3.75. So, since our model is higher than the actual amount, our model overestimates the average ticket price. By the difference between 4.16 minus the actual price, which was 3.75, or 41 cents. Okay, for Part B says, does the mathematical model underestimate or overestimate the average ticket price for 2010? So Part B, and we're going to use the same formula, except this time our N for 2010, the difference between 2010 and 1980, is 30. So that's how many years have gone by. So we plug that in, 0.17 times 30 plus 2.46 from our original formula. And 0.17 times 30, if you enter in your calculator, that's 5.10 plus 2.46. So our estimate is $7.56. Well, if we go back up, we can see that the actual price is $7.21. So our actual is $7.21. Our model says that it's $7.56. So we have an overestimate again by, we'll take the difference, 756 minus 721, which is a difference of 35 cents. So we've used a mathematical model to compare to actual data to see how well our model actually fits the data that we were provided. That concludes section 1.1 for this lesson. Good luck on your homework. Please let me know if you have any questions, and I'll see you in the next one.